All right. So to get started, I'd like to introduce Mike Purtell as our guest speaker. Mike is a principal test engineer with deep expertise in test, program development, board design, and platforms like Advantest and Teradyne. He excels in PVT characterization and ATE yield correlation, leveraging his Python programming skills to craft advanced data analysis and visualizations with libraries such as Pandas, Polars, and Plotly. Mike is also a key contributor to the Figure Friday series on the Plotly forum, which we'll also talk about today. Hey, Sebastien, how are you? In today's session, we'll be highlighting Mike and his experience with Plotly, as well as his work as a test engineer. A few of the areas that we're going to be covering today are Polars versus Pandas, like comparing between the two powerful libraries of data manipulation. The growing with Plotly visualizations. We're going to look into insights into creating impactful and scalable visualizations, and Mike will show us a few visualizations that he has built. And using Plotly as a test engineer, so leveraging the visualization tools to enhance test workflows. Sorry for my allergies. All right, well, let's get started. Mike, how are you?
I'm well. How are you, Adam, and everybody else out there? It's great to speak with you all on this. Feels like a Figure Wednesday, or what is it, Tuesday? Yeah,
it's a Figure Tuesday, a middle Figure Tuesday. Thank you, Mike. I'm doing well. So to get started, can you tell us just a little bit about yourself?
Sure. I'm a native of New York State. I've lived in California since the 1980s. I was educated as an electrical engineer. At my core, I'm a hardware guy, and I tinker with meters and oscilloscopes and everything. So after I graduated college on Long Island, Stony Brook, I moved out to Silicon Valley, and I've been in the semiconductor industry ever since. You probably remember Figure Friday a week or two back where I highlighted these companies in the Silicon Valley, and there's so much more beyond that. But I live in a region that was known for semiconductor development, for the explosion of the semiconductor technology in America and, frankly, the world. And that all started in the early 70s, late 60s. And in 2000s or so, this region became more known for software developers. Big companies like Facebook and Apple and Google are all here. So it's a very technology-rich region. But I'm blessed to have been working on the stuff that I studied in college, and I've really enjoyed it my whole life. And there's definitely a data analysis and visualization angle to my work that I'll be showing some of you people.
Mike, so you went to college, you studied engineering, and then when you left college, did you go right away into the semiconductor industry?
Yeah, basically the semiconductor industry or companies that were heavily involved in using semiconductors for development modules. But most of my time has been spent working directly in the semiconductor business.
And was it more focused on hardware, where you're actually fixing things with your hands, or how much of your career was focused on software versus hardware?
Yeah, that's an excellent question, Adam. It's really been about 50-50. And the reason is because when I say I'm involved in test of semiconductors, primarily what I mean is production test, where you may be producing tens of thousands or hundreds of thousands of units in a quarter or a month or whatever. And so you have to write programs on this very sophisticated equipment that can take a complex circuit design and test it in a small number of seconds. So it's been really a lot of both. You're programming equipment that generates waveforms and makes measurements, and you're always fighting with measurement accuracy or signal path circuits that can affect your measurement for good or for bad. And you got to find all that stuff and optimize it.
Can you share, Mike, how your career and the tools that you've used evolved over time? What would you use when you first started out of college?
Yeah, that's such a good question. So I started working on equipment from a company called LTX. They're based in Boston. And this was in the 1980s. We were doing test programs in an old version of BASIC. It was very primitive. and they had like a canned histogram routine that would make a text-based histogram. And quite frankly, I look at it from today's view, it seems very primitive, but at the time, that was the most advanced computer usage I did in my life. You know, I didn't have a PC at home. And, you know, it was kind of clunky, but it more or less got the job done. If you look at a distribution of parts with any histogram tool, you can tell how well you're placed with respect to what your targets are. And repeatability is a big thing we always look at in the field of test. But
So that was with basic, and then?
And then I migrated to other testers that had used more advanced languages like Pascal, C, C++. Now I'm primarily using a tester that's based in Java, and that's an advanced test machine as well. And it's you know, it's nice they've evolved.
So from all the programming languages, the several programming languages that you learned, was there one that you particularly enjoyed?
Well, I love Python, which is where I am now, but I'm not really doing much in the testing world of Python, just the data analysis. I'd have to say that one of the favorite languages for me was the first version of BASIC. And I think that's like, you know, your first dog or your first, you know, romantic partner will always have a fond memory throughout your life. I think it may be something like that. But yeah, this was BASIC where variables could have no more than 2 characters.
Wow.
And the integer variables had to start with the letter I through N. Easy to remember, right? And otherwise, it was not an integer variable. But I like them all, but I guess in some cases you use a language that is so complex and powerful, it goes way beyond what you need to test and measure parts, that you can get a little bit distracted in its capabilities and not be getting the job done.
So you said Python you really enjoy right now. When did you start learning Python, and like for what reason?
Yeah, I started using it 10 years ago. And the main reason was I was using a Python library from National Instruments to control electronic measurement equipment. So you can connect all these instruments to your PC and give them a unique address. And with this National Instruments library, you can send commands to each instrument to set it up or force it to take a measurement and return a value. And that still today is a very widely used Python case.
Oh, okay. And what led you, once you've learned Python, you got, Esther, you wanted to ask something? I see you were on mute, unmute. I can't hear you, Esther. If you wanted to ask something, why don't you write it in the chat, and I'll forward the question to.
No, sorry.
Mike. No problem. Mike, so learning Python got you a little bit closer to Plotly. What do you remember? At what point you started learning Plotly?
Yes, I absolutely remember. I had heard at one time how cool Pandas was. I remember this is like 2016, and 2 years later, I went out and decided to learn it. So I bought the first Pandas book, which was the book by Wes McKinney, the guy who invented Pandas. And with books like that, I read it from cover to cover. I did as many exercises as I could. And at the end of it, he covers some of the visualization tools. And he brings up like a Matplotlib, Plotly, and others. And, you know, Plotly had the best interactive capabilities. I mean, I was so impressed by that. And it really dawned on me that rather than send my colleagues like a 300-page PDF with static histograms and just drive them crazy trying to figure out what all of them mean, I could just create interactive files as HTML, share them with my colleagues, or use them at meetings to communicate my findings. And the people I worked with loved it. And these are people who they don't know how to use Python or, you know, Plotly or Pandas or anything, but they know how to open up an HTML file and drill down for what they are looking for.
So you mainly use it for work?
Mainly for work. I have a side hobby, which is I work for the Democratic Party in my county of Santa Clara, and I do some election analysis in Python
Nice.
and Plotly as well.
And Plotly. Cool. Now, you mentioned Pandas you learned in 2016, but I see you a lot on the Figure Fridays using polars. When did you start using polars and for what reason?
Yeah, I started about a year ago, and what drove me to polars was I'd heard about it maybe like a year before that, so I'd had like one eye open on it, and the speed improvements were too hard for me to ignore. So I had some, I get some very large files with sometimes hundreds of thousands of devices that are measured, and it takes a lot of time to process these with pandas. It takes like several minutes, and I started using polars for those files, and I got the time much reduced. Um, and as I realized that benefit, I also realized that I just like the syntax better. Pandas is nice. I mean, there's no doubt Pandas is the foundation for so much of what we're doing these days. But the narrative they say came for the speed and stayed for the syntax is really applies to me. So if I have like a set of 50 data points, I still go with polars, even though the speed is not effective.
Is there anything that you still would go back to Pandas for?
Yeah, when polars doesn't work, there's a few use cases where I for whatever reason I'm not able to do the job in polars. So you can stick a two pandas at the end of your polars array if you pass it to a data visualization tool or some command that is not really set up yet for polars data frames. But they're
Because Pandas is a lot more mature, a lot older, right? So it probably has
yeah,
more methods and functions than polars does.
it indeed it does. I mean, I'm a pretty specific user, so I come across things that don't work in polars, but it's not that frequently. I think there's probably others who encounter that more often than I do.
Okay. It is there like if somebody was to ask us on the forum, like my or people watching this video later, this recording, Mike, when do you recommend I start using polars and when do you recommend I use pandas? Is what would you say?
Well, if somebody doesn't know either one of them,
Yeah.
I would probably say just go to polars because I do think it's newer. It's probably, it's still growing. I think it's easier to learn. I thought,
Oh, okay.
I thought pandas had a very steep learning curve. I mean, it took me a long time to get as
Because of the
confident.
syntax?
Yeah, because of the syntax. Maybe it's the programming style, but I found in pandas there's so many ways, different ways to get the job done. And if I looked at some of my old code, and you realize like, why did you do it that way? And usually the answer for me would be because the other ways I tried didn't work, and this one did.
Okay.
And beautiful or not, it works. Um, but
Okay.
the one thing that really affected my journey in this is when I decided to step up my skills in pandas, like 2 years ago, I got this book from Matt Harrison, Effective Pandas, and it was so consequential on my coding style, and it made me so much better at pandas, and not to be passing data frame to data frame to data frame and getting these on copy warnings, all those things, but really structured program, chaining commands into a readable flow is all very good.
Awesome. All right, Mike, I want to take the conversation back to Plotly because you started working with Plotly for work, and now you do it on the side. One thing you mentioned on the side is the volunteer work you do for election analysis, but you also do, it's not a secret, anybody that's active on the forum even a little bit knows that you're very active on Figure Friday, and you post like beautiful plots there. What made you get started with Figure Friday?
Well, one thing I've always faced in my work is that all the semiconductor companies, their data is their crown jewel. We just don't, they just don't share data publicly. And so, how does somebody get to up your skills with tools like Plotly without exposing, trade secrets and proprietary information? And so when Figure Friday first started in early 2024, I believe, the light went off in my head that Plotly's going to provide a data set every week, and people like most of those on this call can collaborate and share their visualizations and tips and help each other out. And, that struck a chord in me as just a great way to get up to speed and improve your skills with Plotly. And one thing that can hold you back from growing your skills is when you are working in a niche kind of application and you're only doing like one thing over and over again, you don't really get exposed to the breadth of capabilities that a tool has. And so that's what I liked about Figure Friday, and still do very, very much, is, we never know what's going to come out from week to week, but it's usually very, very interesting, and it's a lot of fun. But it helps me professionally and personally, and I just really enjoy it.
Thanks, Mike. So
very nice people in this group.
Yeah, I completely agree. For those who are just watching the video, Figure Friday is a weekly initiative where we release a data set either Thursday night or Friday morning that the community comes together to work on. Now, this is a relatively, usually small data sets, a couple megabytes, and the goal is to create figures or Plotly visualizations on top of these data sets. If people want to create a Dash app, they can also create a Dash app on top of these data sets. They have 1 week to do it until the following Thursday when a new data set comes out. And then we have Figure Friday sessions at noon Eastern time every Friday to support each other, give each other feedback, and talk about the figures that we build. So I want to give an opportunity before I jump into, I know you created a few pretty cool visualizations that you want to show us, Mike, but we did cover a lot of information here regarding Plotly, Pandas, polars. Does anybody here on the call have a question about what Mike just talked about? Any question about polars or Pandas or the usage of Plotly? I'll give you a couple of seconds. If you want to, feel free to unmute yourself or write in the chat. And if not, we'll move on to the next topic.
Yeah.
Marianne.
Yes, Mike, you mentioned a very good book for Pandas. Are you going to put the title in the chat, or?
Yeah, I can do that. Sure. It's.
I can write it, Mike, in the chat. What's the title?
I believe it's Python for Data Analysis by Wes McKinney.
By Wes would be WES.
Yep.
MC McKinney. MC.
McKinney.
Okay, got it. There you go, Marianne. Great. All right, Mike. So you did prepare a few cool visualizations. Do you want to share a screen and show them to us?
Sure. Go ahead and do that. Okay. Sharing is not
allow. Yeah, Mike is requesting allow. There you go. Now you should be able to share.
Okay.
Mike, as you're loading the screen, Esther is asking, what code editors do you prefer for Python?
Lately, I'm using VS Code, but I never really thought of it that much. Before I used VS Code, I was just coding directly into Jupyter Notebooks or Jupyter Lab, or I used to use an IDE called Anaconda Spider.
Right, I remember that one.
But now I'm mainly using VS Code.
But between the three of them, if you have some experience with Jupyter, Spider, and VS Code, now do you have like a preference, or they're all the same to you?
I'm mainly using VS Code now. I think it's a little bit more advanced. It supports straight Python or Jupyter Notebooks. It's got hooks into Git.
Okay.
I'm enjoying that. And as I see people make presentations at Python events, like our local Bay Area group called Bay Piggies, or different Python conferences. I'm seeing more and more people who are presenting live Python code or bringing it up in VS Code.
VS Code, all the live part. Cool.
So,
Mike?
Okay, you can see my screen, everybody?
Yes.
And let me ask you guys a question. Has anybody here ever heard of a shmoo plot?
Not me.
Didn't think so. So that's a term that my industry has been using widely for like 50 years. And basically, it's just a grid with colors to show the relationship between X and Y coordinates and a measured value or a binary result. But I like to say my industry was doing big data before people talked about what big data was, because when you test like 100,000 devices, you get a mountain of data and you got to process it. But let me start out with this one. This is what we call a wafer map. And a semiconductor wafer is approximately round, but you can see it's diced into small, each square represents a device. So it comes out on this big round flat piece of silicon, and we test each device one at a time or four at a time, and we keep track of which ones passed and which ones failed.
Mike, so there are typically hundreds of devices within each wafer?
Hundreds or thousands. It just depends on how big the die size is. They can get really small and have many, or they get very big and have maybe only 100. But if I can impart one more thing to you guys about semiconductors and the way they work, and let's face it, these devices are in everything, right? They're in your toothbrush, they're in, your car, everything has them, right? When you make this kind of a semiconductor wafer, on a good day, you'll probably have about 97% that are defect-free. Because, impurities in the air, even in a clean room, they get embedded into one of these chips and it breaks. It doesn't work. It doesn't do everything it's supposed to do. So think of where we would be if you built, like, let's say, an iPhone or a gaming device, and only 97% of the ICs in it worked, and you had 100 ICs in it, you're going to be buying products that are more likely to not work than work. So the main object of testing is, we got to find those devices that are not good and make sure they don't get sent out as good product. So what do these colors mean? This is for testing a full wafer, and the red cells are just indicating where a device failed. Because when you get done testing this thing, they're going to cut this wafer up into the individual squares, and you have to separate the green from the red and make sure the red ones don't get shipped to your customer or built into an end product. So it's very, very important.
So what, Mike? So here, like the bad products, you'll remove them from the wafer. Is that what you mean?
Yes, I mean, after we test it, the wafer is cut up.
Okay.
Right. So each square is a separate device. And we have to pull out the red ones. We don't, those are the ones our measurements said are no good. So we have to separate them from the ones that are good. Because if we don't do that, we're going to have a very high rate of fail. So this is one of the most basic visualizations. We take a tested wafer and send it to a subcon that does this. We call it dicing, where they actually run a saw through all these lanes and cut it into individual die. It's an interesting process. It really is. So what is this telling me? This is telling me how many dice there were, how many passed, how many failed, and just a yield number. I mean, everybody in manufacturing is concerned about yield. You have to pay just as much to make the bad devices as you do for the good ones, but you got to take them out of your flow. Now we can go to a little bit more level of detail. This is just telling you which die passed or failed. And what does a failure mean? You may be running like 50 different measurements or hundreds of measurements. A failed device is a device that failed one or more measurement. So it could be good in every single way, but failed one thing, so it's overall failure. So right now, I can't tell if this device failed one test or maybe it failed them all. Can't really tell. We can go into a little bit more detail. This is a heat map map for a specific test. And what we're looking for here, this kind of reflects the manufacturing of the wafer, because you can kind of see from this bar that the values in the center of the wafer are quite a bit different than those on the edge of the wafer. You know, sometimes that's just natural due to the way wafers are constructed, but sometimes it isn't. And in manufacturing, we have to pay attention to this stuff because, you know, once in a while you may have parts that yield 90% consistently, and then you get a bad run and you're at 50%, and you have to figure out what went wrong. Did your measurement equipment go south? Was the wafer poorly made? And making these things is like a pizza. You know, you leave it in the oven a little too long, and it's not a very good end product. And you know, there's definitely sensitive recipes for making these products.
Mike, but what do we see? This is a wafer with a bunch of different devices, like we saw before. And
yes.
Why is the color here continuous as opposed to discrete?
Oh, okay, yeah, good question. Well, this discrete coloring is just pass and fail, right? It's just good and bad without any grading of what was good or bad. This is representing just one specific measurement. So I can break this down further into, instead of like, in essence, this is binary data, right? Pass, fail. This is data that represents, you know, an analog numerical floating point value. And so you can see the performance difference, and you have to look at it through the lens of, well, what is the, you know, what is the requirement? I mean, some variation is okay. You have target limits, but some isn't. But it's something where this kind of visualization, you can show it to process engineers, design engineers, and everybody can more or less understand it. And, you know, the beauty with Plotly is I can just send them these files or put them in a shared drive, and anybody else can do this kind of deep dive. So what we're looking at is, I love the hover capability in Plotly. What it shows me is I'm hovering on a die at address 1640. That's just like the X and Y coordinate. The measured result is the, you know, this is the value from a current meter, 0.842 microamps. And then I call this test, pass, or fail because it's just reflecting this specific test, not the whole wafer. So this test has a 99.9% yield. So we're not throwing away too many devices from this particular test, but it's a little more interesting when you get some extreme cases. And this is a different test. It's a frequency measurement. You can kind of see a striping effect on here. You know, there's an interesting pattern, and I'll show you what that is in a second. But let me move on to the next one. So we spend a lot of time, you know, histogram is, this is a histogram of one measurement. And I'm showing the upper and lower limits. This is what I judge the result by. So anything outside of these boundaries will be made into a failure. And this test site information is, we test more than one part at a time. It can be 4 at a time, 8 at a time, depending upon your hardware configuration. What this is showing me is that the devices measured on these 4 sites are all pretty comparable on this specific test. Not much difference. I mean, this is what I would say I like to see in a manufacturing test scenario. So I threw out 1.9% of these parts, but the distributions look pretty well controlled. You know, when I see a test like this, I go, okay, that's pretty good. I might see the mean shift and the yield go up and down in the future, but, you know, overall, this isn't bad.
My quick question here, if I may.
Yeah.
From what, let's say the things that passed here, we see that 98.1% passed. It looks pretty good to me in that the mean is, there's a big concentration in the middle between 11 to 13 supply current, which seems like pretty ideal. But what happens if you have a 99% yield of tests pass, of devices pass, but there's a big concentration like between the 10 and the 11 or to the extremes. Does that affect like how you might pass the device or not? Does that even happen? Whereas you will see a different type of chart where a lot of the concentration is not necessarily in the middle, but towards the extreme, although it's passing.
Yeah, that does happen. You get distributions that are a little bit skewed. You get so-called a long tail.
Okay.
That very much happens.
Okay, got it.
The other parameter that is used in manufacturing is called process control, or CP or CPK. And whereas I like this distribution, some people would reasonably not be as comfortable. They like to have these test limits that are maybe 4 sigma away from the mean instead of like 2 or 3, because they realize that in this distribution it looks great on a golden wafer, but if there's if this moves by, let's say, 1 milliamp to the left or right, you're gonna be throwing away a lot of devices, right?
Right.
If you move these limits over. So, when you put something in manufacturing, they like to have test limits that can hold up over the test of time, but at the same time, they have to screen the parts so they work in the customer's application. It's an endless task of horse trading with marketing people and agreeing on how you're going to judge the parts. But I mean, this is as basic as it gets. This is a Plotly histogram. I created this one with graph objects instead of Plotly Express, and the reason is for overlaying the histograms. I think that's really not possible in Plotly Express. I'm not sure. That gives you a stacked histogram. So I use the graph objects for that.
Okay.
The next thing I wanted to show you was we spent a lot of time in tests trying to correlate two independent measurements, because you're always looking for, does one behavior allow you to predict another behavior on a device? And this kind of steps into machine learning, by the way. It's just simple prediction, but here I've plotted two tests against each other. You can see there's basically virtually no correlation, right? There's a R of minus 0.02. This best fit line is just, buried in noise. That's okay. This is where you see other tests that do show you a strong correlation, and it's useful to understand when that happens. In some cases, people look at these correlations as a way that maybe I can skip doing one of those measurements and save production time, because if one can be used to predict another, why not? Best fit line is considered a machine learning task, believe it or not. These AI terms are mostly kind of new to people, like let's say in the last 5 years, but some of these things like linear regression, calibration, those are all early examples of machine learning, at least according to one of the books I read. And so we go through this kind of procedure quite a bit. And a lot of this work is detective work too, because I'm looking at data for testing that's done before we ship parts to customers. Sometimes you get a part back from a customer that they said failed or didn't work, and you have to take their part back and remeasure it and pull out the device's test data from before it shipped and just try to figure out, is it a valid test escape? Was there something we could have done to predict the failure the customer saw, or is the failure even legitimate? But all this data really, really helps a lot. And the last one I prepared to show you is this is like that heat map of the input leakage, but I put it into a Plotly surface contour map. So what we're seeing is the 3-dimensional view of that heat map I showed you earlier. And you can see the low numbers in the middle of the wafer, and it just kind of increases like a cone.
Yeah.
And Yeah, I don't use this one so much, but when I really need to make a point of the fact that maybe a wafer has such a difference depending on the radius from the center, this is a great way to do it. And
And in
I
this
think
case, Mike, the ones in the middle are the better ones or more efficient ones, or the one on the top of the cone?
we would say the middle, because input leakage is the amount of current drawn by an input signal, and ideally it would be zero, but it's not. So yeah, the
Okay.
ones in the middle would be better in this kind of test. And I think one of the first things I ran through Plotly was, you've all seen the famous Mount Bruno 3D plot.
Yeah.
It's just so cool and so captivating. But
Yeah.
so we in the field of production, manufacturing, test, we've had a lot of tools come and go over the years. There's tools that are provided by our test equipment suppliers that are really specific to what they do. And there's tools that are really specific to my industry. But I think they are inferior to the general purpose solutions that you have from Python and Plotly and others as well. But that's kind of my focus.
Mike, do other people in your company also use Plotly, or is mainly you showing people the Plotly charts?
We have others, not too many though. It people are such creatures of habit, and they have a tool they've been using for many years, and they don't want to change it. But this kind of stuff leaves them in the dust. It really does.
Really nice.
So
Thank you, Mike. Anybody have any questions about the visualizations that Mike has shown, or how he uses Plotly at his job? Things were pretty clear, but just in case anybody has a question and wants to comment. Mike, how, as a test engineer, are you the one that's also like the one that decides on those limits of, let's say, the supply current and what
yes.
fails and what passes?
That's an excellent question, Adam. And the short answer is no, but I have influence. And what I mean by that, let's talk about this plot for a second, though. Site 3 has a different center than the other two.
Yeah.
And this is primarily the reason why this wafer yielded 80% instead of high 90s. So this is indicating a measurement issue, because the devices should all be of similar performance. So there's a bias on site 3. But let's look at the other one that isn't this bad. So for this kind of test limits, who decides it? Well, it's usually by committee. So you'll have people in the manufacturing side that are interested in making money. You'll have people in the marketing side who they have commitments to the customers. They think, okay, maybe this parameter gives them an edge in sales, and they don't want to use the wide limits that these distributions imply that you should. So there's always a little bit of horse trading on that, but I'm on the side that wants to have the limits as wide as possible. But the team has to have we call it a limit setting meeting, and we get together in a room for a few hours, and we go through the major tests, look at the distributions, and say, here's what we're capable of seeing on our manufacturing equipment. So in this case, if you want to have a supply current that's no more than 12 milliamps, for example, you're going to be throwing away half of the devices. And usually that's a no-no. I mean, unless you've got a really special case where you're selling something for a very huge premium. If you look at the big companies in this kind of analog world, like Texas Instruments and Analog Devices, they wouldn't think too kindly about setting a limit that's too tight. But it's a team decision.
Okay, got it. Like, there's a question here from Marianne. The assumption here is you might have used other visualization libraries. This could make answering the question a little bit easier, but how do you think Plotly is better than the other visualization tools? Like, what do the other tools lack that Plotly does have?
Well, primarily I came to Plotly because I liked the interactive capability, and I liked saving these visualizations to HTML files. It's the easiest way for me to share them with other colleagues. And I've learned over this time, especially in Figure Friday, that Plotly is very customizable. I mean, you can do so much to improve the appearance of your visualization, and it gives you all the hooks you need. It takes a little time to master them, but that's something I really like. I mean, others, I guess, can do the same thing, but all in a different way. I mean, I started with Matplotlib, and that's a pretty good tool, but it's not interactive. So, and sometimes the interactivity, by the way, it sounds like it's just like a toy, but if you have a really crowded plot with lots of data, you really need that capability to select and deselect and the interactive hovering. Yeah. So that's what I like. And about, I don't know, 5 or 8 years ago, I was at a user group meeting by Advantest, and their CEO gave a keynote speech, and he mentioned some emerging, interesting technologies, and he mentioned Plotly. And at that time, I just heard about Plotly from Wes McKinney's book. I didn't really know that much about them, but I connected those dots and said, this must be a really cool company. They must be doing cool stuff. And it turned out to be correct.
Yeah, I remember also, like, I started with Matplotlib, and it's very good. It's a powerful tool. It's been around for so many years. You can do a lot with it, but what kept on frustrating me, which is why I moved to Plotly, is that you have to, it wasn't like Plotly, one line of code and you have your chart. You have to define everything, the axes, whatever, the color, the width, it was just, it was hard to remember everything that I had to define just to get started with a plot. So I like that Plotly gave me especially Plotly Express, gave me the capability to write graphs in like 1 or 2 lines of code. And then if I really needed to customize it further, then I could use figure.update traces or figure.update layout. And I have like access to dozens, sometimes hundreds of attributes that belong to the Plotly graph objects library.
Yeah, I noticed that when I write my Plotly code, I tend to have a lot of lines of code because I do these customizations. And one thing that took me getting used to when I first learned Plotly is that each command is a very long string of parameters with dictionaries and dictionaries. And so I realized that trying to do things in one line is really not the best approach, but at least to show the flow of what you're doing helps. So I noticed that I tend to have more lines of code than most, but I really enjoy the customizations and like to have it readable. And it's nice that when you chain everything into multiple lines, it's easy to like just comment out one of your input parameters, for example, to debug and
yeah. Agree. I like your code. I see your codes on Figure Friday. Even the polars are long lines, but it's very readable. I understand immediately wherever I'm in the code what you're doing.
Thank you. I appreciate that. Not everybody would agree with you, but
cool. Well, thank you, Mike. This is great. Appreciate all the graphs that you were showing us. Appreciate all your participation in the Figure Friday sessions and the weekly visualization of Figure submissions. You have really cool apps. And most importantly, I want to thank you for helping others. Like when you're on the forum and you give others feedback and tell them how good they're doing or what you might do differently. It's just incredibly helpful for the health and the growth of the community. So thank you.
Yeah, well, thank you. And if I could give you any tip or advice.
Yes, we do like to close out our Hangouts with like one suggestion that you would give our viewers. What would that be?
a couple things. One is really get to learn and use this Plotly hovering tool. You can see I emphasize that a lot in Figure Friday, but if you deliver this stuff to your colleague and they can interact with the data in this way, you'll be so much better off. And I know, Juan, I have a follow-up item for you on this hovering, and I'm sorry it kind of fell off my plate, but I will get to it. But take advantage of the hover tips and learn to use them well. It will go a long way for when you share HTML visualization with your colleagues. I think they'll really appreciate it rather than the default. The second tip I would say is, be prepared to deliver, a self-contained visualization to your customers or your colleagues. You want them to be able to just open it in their favorite web browser, and you don't require that they know anything about Plotly or Python. All they got to be able to do is use a web browser, and so you can make everything self-contained for them. And that goes for dashboards as well. I'm not a dashboard guy yet, but that would be the same story. And then the last tip I would say is, follow the practices of storytelling with data. It's nice, sometimes I make 300 of these for one product, but nobody ever looks at them all, including me. So create clear visualizations, use the annotation to give the message you want. And, I follow the practices from Storytelling with Data by Cole Knaflic. Really try to present as clear of a visualization as you can. Eliminate the noisy stuff, eliminate things that don't matter, and you'll be very well served. And then the last thing is, and this is a big one, for anything with coding or visualization, is try to do something that's outside of your profession, and you'll just get a lot better at it. So I work in an industry, I've been doing this since the 80s. I've been around for a long time. And I work with people who say, it's really hard for my business to get young people out of college to come into semiconductor test. And then you look at, they write a job a job advertisement, and they're looking for people who know, Perl and old stuff like that. But, embrace the new technologies that come in front of you so that you will future-proof your own career and make it attractive for others to join who are recent graduates and younger.
Thank you, Mike. Valuable advice. As a summary, make use of the hover tooltip in Plotly. Export your Plotly. Know how to export your Plotly graphs into HTML that contain plots, so people can just open them up in their browsers. Try to follow best practices about data with storytelling, right? Whether it's the right colors that you're using, so it's available to everybody. Not too much saturated information, and many, many more that you can read at the Storytelling with Data by Cole something. We'll add that later. And then interact with data outside of your industry. I like what you said, Mike. That was also you said at the beginning of the Hangout. It's when you get you're doing this through Figure Friday, but there's many other ways to do this. Like when you're working with data and Plotly with only within your industry, then you'll probably get very good at it, and that's great. But when you look at data in different industries and different sectors, you will potentially learn a lot more because you get an opportunity to create different types of graphs and different types of visualizations because the data is inherently different. So I like that advice.
The thing that really strikes me is when you're doing something outside of your work and you learn something new and the light comes on and you go, I can apply that to the actual work I do and make it better, but I might not have discovered it otherwise. And that's one reason why, like all the different topics that come up for every Figure Friday and any other application people want to work with can really make you better at all this stuff. And it really carries over too, because this is specific for Plotly, but it can apply in so many current and future contexts. So there's no downside to learning this stuff very well.
Exactly. Cool. All right, well, I'm going to close us out. I want to remind everybody here on the call or the ones watching the recording, we do have Figure Friday every week. This week on the 17th, on Friday, we will release a new data set for the people to work on next week. We have the product launch event, a Plotly webinar, one of our biggest webinars this year, most likely, and our first webinar of the year. I added a link here in the chat in case you would like to sign up. Even if you can't make it on January 22nd, it's still a good idea to sign up because you will get access to maybe later the recording and other information from the webinar. Thank you, Juan, for the name of the author of the book. We also have the Plotly virtual meetup. The community members meet together virtually to talk about the things they're working on, whether it's Dash components, Dash properties they're building, Dash apps, just what's happening around the community and the forum. So join us. The Plotly virtual meetup is a calendar invite. So just email me at adam@plotly.com. Again, it's adam@plotly.com, and I'll send you, let me know that you want to join the meetup, and I will send you an invite. Also, New York City Plotly meetup. If anybody here on the call lives in New York City, or those watching us, we do have Plotly New York City meetups the first Wednesday of every month. We had one in January a couple of days ago, and the next one will be on February 5th. So let me know if you would like to join. All right. Thank you, everyone, for joining. Thank you for your great questions and comments. Mike, thank you again. And
Thank you all.
Have a great week.
Okay.
Bye everyone.
Everybody.